This is an intro to a verification lab that you're going to do. So normally we experiment and we collect data and then we create a graph, and from the graph we come up with a law. I'm actually going to give you the law and then you are going to experiment to verify it is true. So if you look at the handout, under principles and procedures, it gives you this statement. Archimedes' principle states that the buoyant force is equal to the weight of the fluid displaced or pushed aside by an object. And so I am going to derive what that statement means, and that is what you are going to verify. So if I have a container, and in the container, we'll do an object that is fully submersed, and then we'll do a floating object. So I have some liquid, and the easiest thing to do is a cube. I know it's really tempting to do a sphere, like maybe a spherical cow. So this object, anytime an object is immersed in a fluid, there is a buoyant force. So we are immersed in a fluid, the air, and there is a buoyant force holding us up. And so if we were to do a free body diagram of this cube, what we would have is the weight of the cube going down, and we would have the buoyant force upwards. Okay. And so what Archimedes' principle states is that the buoyant force on the cube is equal to the weight of the fluid displaced by the cube. And in the handout it says or pushed aside by an object. And so what that means is we know that weight is equal to mg. So this is the mass of the fluid times g. And we want to figure out what is the mass of the fluid. And again, this is displaced. I should have written that down there. So the mass of the fluid displaced is how much is pushed aside by the object, and the amount that's pushed aside by the object is actually just the volume of the object. Okay. And then so we need to figure out what is the mass of that. And so in order to figure that out, we know that the density of the fluid is equal to the mass of the fluid over the volume of the fluid. And this mass of the fluid and this mass of the fluid, that is what we are looking for. So we're going to solve this equation. We've got the density of the fluid times the volume of the fluid is equal to the mass of the fluid. And we need to do one more thing. We know that the volume of the fluid displaced is just equal to the volume of the cube. So what I colored in. And so we are going to substitute this into there. And so what we end up with, we go back to blue, is that the buoyant force on the cube is equal to the density of the fluid times the volume of the cube times g. And again, just remember, you won't be able to see that, this is the mass of the fluid. And so this whole thing, this is the weight of the fluid displaced. Now, my recommendation is you actually try to derive this, because as you derive this, then it will start kind of getting cemented into your brain. I want to do one more example. So we're going to do an example with a cube that is floating. And so I've got my fluid, I've got a cube floating. And now the I've got this is the fluid displaced. So this part right here is the fluid displaced. So I'm still going to have that the buoyant force on the cube is still equal to the weight of fluid displaced, but now since the cube is floating, I have less that is displaced. But I know that I still have, this is still equal to the mass of the fluid displaced, or again, pushed aside. In other words, how much is under the water. So the mass of the fluid under the water times G. And we should, again, just to emphasize, this is the fluid displaced by the block. In other words, there was originally some fluid here, but the block pushed it aside, and so it's the weight of that that fluid that was pushed aside by the block is what the buoyant force is equal to. So buoyant force is equal to the weight of the fluid pushed aside by the block. Hopefully I'm not being too redundant and this is actually being helpful. So we're going to go back to our formula. So this is going to be the density of the fluid, and this is times the volume, and we're just going to say of the cube or object underwater, because that is the volume that is displaced. If you have a sphere, then it will be the sphere. Usually I just use generic object, and then times G. Okay, so what is the cube underwater going to be? We will define some H, and then we will assume that the bottom is length times width. And so this will be density of the fluid times the length times width times the height underwater of the block. And then times G. And so that is equal to the buoyant force. So in the lab, you are going to measure the volume that is displaced directly by having, as you put the cube or object into the water, let me go. So you're going to have a container, you're going to have a beaker that is filled to the top with water. So water's everywhere. And you are going to insert an object into the water. And when you do that, the water is going to overflow into a graduated cylinder if you do this correctly. And so you will measure the weight of that water, or the volume of that water, and then you'll use the identity that 1 milliliter of water is equal to 0.001 kilograms. So we need to go to kilograms. This is water only. Need to go to kilograms in order to calculate force in newtons. So already way too long than video's already way longer than I wanted it to be. Hopefully this helps.